All right, welcome back, everybody. Objective 4 for our GOB review is just finding area. Okay, we're going to look at finding area of a bunch of different types of geometric figures. Let's rock and roll. All right, so starting off with area formulas for basic shapes. Starting off with a rectangle. Area of a rectangle, we're going to say, is just the product of its base and height. Okay, so B times H. And we could think of this as length times width or length times height, but we're going to think of it in terms of B and H, just because we're going to see that B and H, base and height, show up a lot as we go through the rest of the chapter, along with some other chapters in geometry here. Okay, area of a parallelogram is going to be the same formula, product of the base and height. Now the difference is with a parallelogram, any of the sides can be the base, and then the height is the perpendicular distance between my bases here. Okay, so the height of parallelogram is not a side length, it's a distance between the bases. So let's go ahead and use that formula for area of a parallelogram. Okay, what's the area of each parallelogram? Part A, well, my formula I know is area equals base times height. And then notice for this one, I gave you two of the bases. We've got 10 for the bottom, and I suppose the congruent top, and then 9 on the left and right sides. Okay, but I only gave you one of the heights. So the base I have to use for this one is the 10 because I have its corresponding height. All right, I have no clue what the height is for the 9. If I knew it or if I saw for it, I could use it. Okay, but I got to use the information we have in this question. As part of this question is sorting out, which parts do I have and which parts can I use. Okay, so once you've identified that, pretty straightforward. Area equals base times height, just 10 times 8. All right, so we can say area equals 80 inches squared. Square units because we're talking area. All right, part B is a similar question. Why don't you take a minute, pause the video, work through part B, and then before you move on, throw a hand up in the air, get your answer checked. Make sure you're good with kind of one question before you move on to the rest. Next shape we'll look at is finding the area of a triangle. I'm going to say the area of a triangle is half the product of the base and its height. So in other words, from this formula, half times B times H, essentially we're seeing that a triangle is just half of a parallelogram. So don't forget that half when you're using this formula. And then again, with the triangle, just like a parallelogram, any of its three sides could be the base. We'll think of the bottom as the base for this diagram. And then the height is going to be that same perpendicular distance from the base to the opposite vertex. So once again, we're going to have to make sure we're using the right dimensions when we use that formula. So let's go ahead and use that triangle area formula. And we'll run through a few examples together here. So what's the area of each triangle? Part A. Now you're going to notice I'm going to rewrite this area formula every time I'm going to use it. Okay, for basically every shape we go through here today. Okay, good habit to be in, so I'll write that formula out, then I'll fill it in with the information I know. Okay, so area equals half times base times height. Now once again, with this triangle, I gave you all three of the bases, all three of the sides, but I only gave you the height corresponding with the bottom base. So that's what I have to use here. So we can just say area equals 1/2 times the base. I've got to use this entire distance. So 5 plus 8, in other words 13. Okay, times the height 6. Now when I multiply all that together, I get a 39 for the feet squared, we could say. Okay, let's go ahead and do one more together. Once again, area of a triangle is equal to 1/2 times base times height. And once again, with part B, I gave you all three sides, so I have all three bases. Now, with the base on the bottom, the 10.8, notice I didn't give you the height for that base. Okay, so I can't use the 10.8 in this one. The trick with this problem is since the 9 and 6 are at a right angle to each other, we could think of 9 as the base and 6 as the height, okay, or vice versa. So either way, it's when you're doing right triangles, you are going to use those actual side lengths. So here I'd go 1/2 times 9 times 6. In other words, we're going to get a 27 yards squared for this one. Okay, so as you can see, there's some different ways we can mix these triangle problems up based on the information we give you. All right, part C is another example. Once again, take a minute, pause the video, work through that one, throw a hand up in the air to get your answer checked. Okay, get that checked before we move on to the next question. Now that we have the area formula for a few basic shapes, we can actually get into more complicated shapes right off the bat. Okay, we can look at finding the area of irregular figures. And an irregular figure is just going to be a more complicated shape made up of simple shapes put together. So problem A says, what's the area of the figure consisting of the rectangle and triangle? Basically, our approach for this is going to be split it into shapes we know how to find the area of, and then add them together once we have each of the individual areas. So to do that, like it says, there's a rectangle and a triangle. I know how to find the area of a rectangle. That's just base times height. So we can say 12 times 5, which will give us a 60. And then the triangle is going to be a little more complicated for this. Remember, area of a triangle is 1/2 times base times height. Now, as far as the base goes, what I can do is I can steal this 5 from the left side of the rectangle and bring that over. So I know this will be 5 as well. And then I have the base. I need to figure out what the height is. And the trick for that is the problem gave me the distance or the kind of width of this entire figure here, 16. So if I take that 16 and subtract 12 off, I end up with a 4. Okay, and 4 is going to be the remaining distance. 4 is going to be that height. Okay, so filling that formula in then, we have 1/2 times base 5 times height 4. In other words, we have a 10 for the area of the triangle. All right, my total area then will just be the 60 plus the 10. In other words, 70, and we can say centimeters squared. Okay, so that's how you break down a irregular, complicated figure into smaller figures that you can find the area of. Part B is the same idea. Why don't you take a minute, pause the video, run through that one, and then, like usual, check your answer before we move on to the next one. Next type of shape we'll look at finding the area of is a trapezoid. Remember, a trapezoid is a quadrilateral, four-sided shape with two parallel sides, the bases. We'll say the area of a trapezoid is half the product of the sum of its bases. So in other words, area equals 1/2 times height times b1 plus b2. And then just like with the parallelogram, just like with the triangle, we'll say the height of the trapezoid is the perpendicular distance between its bases. Okay, so distance from base to base at a right angle. All right, so let's go ahead and use that area formula. What's the area of the trapezoid? We just said that area equals 1/2 times height times b1 plus b2. All right, so this one's looking pretty straightforward. Let's plug in what we know. We've got the half. Okay, we've got the height, distance from base to base, which will be 7.5. And the times base 1 plus base 2. Now again, my bases are my parallel sides. Doesn't matter which one I think of as 1 or 2. We can put them together in either order. So we'll just say 9 plus 22. Okay, if I multiply this all out in one step, I do need the parentheses here. Okay, so make sure you plug those into the calculator. And multiplying things out, I get a 116.25 for this one. And we could say meters squared. All right, so that's finding the area of a trapezoid. Part B in the note guide is the same idea. Take a minute, once again, pause the video, work through that one. Make sure to check your answer before you move on. Next set of shapes we're going to take a look at are rhombuses and kites. And we're going to group these ones together just because their area formulas are the same. Okay, we'll say the area of a rhombus or a kite is half the product of the length of its diagonals. So 1/2 times d1 times d2. Where, when we say the diagonal of a quadrilateral, that's just the distance all the way from corner to corner here. All right, so let's go ahead and use that formula. Now, we're finding the area of a kite, but once again, this is going to work the same way if we had a rhombus. Okay, if you remember back from our unit on polygons, rhombuses and kites have a lot of the same properties. We just said area for a rhombus or a kite is equal to 1/2 times d1 times d2. All right, so we've got the 1/2. And again, as far as the d1 and d2, we're talking about diagonals. Once again, it doesn't matter which one we think of as d1, which one we think of as d2. Okay, I'm going to think of the one going from upper left to lower right as my d1. And it looks like in this case what I'm going to have to do is add the two chunks of that diagonal together. So we'll go 3 plus 3 is 6. Okay, then we'll say d2 is the other diagonal, so that's going to have a length of 5 plus 3, in other words 8. So 1/2 times 6 times 8, we'll end up with an area of 24, and we can say centimeters squared. Okay, so that's how to use that area formula for a kite, and then again, it works as well for a rhombus. Part B is the same idea. Once again, pause the video, work through that one in the note guide, and then check your answer before we move on. The next thing we're going to look at is finding the area of a regular polygon. Remember, a regular polygon is a polygon with all sides congruent and all angles congruent. So there really are nice polygons, are nice hexagons, pentagons, octagons. And we're just going to say that the area of a regular polygon is half the product of the apothem and its perimeter. Okay, where the apothem is the distance from the center to the side of the regular polygon. So in this picture here of a regular hexagon, the apothem A is the distance from the from the center to the bottom side at a right angle. So it's kind of like half the height of the polygon. So it's 1/2 times A apothem times P, where perimeter stands for the distance around my figure. All right, so let's go ahead and use that formula. Problem 6, what's the area of the regular octagon? We just said area equals 1/2 times apothem times perimeter. So 1/2 here we have times the apothem we're given, the 14.5, distance from center to a side at a right angle. And then times P for the perimeter. Now what I'm going to do for that is I need to add all the side lengths together. Easiest way to do that is just multiply the side length, the 12, by the number of sides. So we can say 12 times 8, because we're talking about an octagon here. All right, essentially what this formula is doing is when I do the 1/2 times 14.5 times 12, is I'm essentially finding the area of one of the triangles, kind of running from a side length to the center. Okay, 1/2 times base, the 12, times height, the 14.5. And by multiplying that by 8, that's going to take care of all 8 of those triangles that would be formed, okay, by all 8 of the sides. Okay, so plugging that in, you can do that all in one step. And when I do that, I end up with a 696 centimeters squared. All right, part B, once again, same idea in the note guide. Again, take a minute, pause the video, run through that one. It's going to be a different type of shape, not an octagon, so not quite the exact same thing. Okay, make sure you check your answer before you move on. And we're going to finish this lesson by doing a few different things with circles. We're going to start off by finding the circumference of the circle. Remember, the circumference is just the distance around the circle. So essentially it is the perimeter of the circle. And when it comes time to find the circumference, we can either use the diameter, distance all the way across to the center, or the radius. I can say the circumference of a circle is just equal to d times pi, diameter times pi, or 2 pi r, 2 times pi times the radius. Okay, since the diameter is just double the radius, those formulas are essentially doing the same thing. Alright, so let's go ahead and use those circumference formulas. Problem 7, finding circumference. Now the big thing to pay attention to here is, did I give you the radius or did I give you the diameter? Here it looks like I gave you the diameter, distance all the way across. So for finding the circumference, I'm just going to use my c equals pi times d formula. Guess what I can do is just say pi times 15, alright, or I could just call that 15 pi. Now that's going to be my answer in terms of pi. It's okay to leave it like this, if that's what the question's asking for. Alright, or I can approximate that by multiplying by pi, just taking 15 times the pi button on my calculator. That would give me a 47.1 centimeters squared. Okay, a little more practical answer, but this is an approximation. Okay, this 15 pi would be exact. Alright, I guess with that, as far as in terms of pi, not in terms of pi, just pay attention to what the question's asking for. Alright, that's finding circumference. Part B in the note guide is the same idea. Once again, take a minute, pause the video, run through that, check your answer before you move on. Alright, we're going to follow up finding circumference with finding arc length. And what arc length is a fraction of the circle's circumference. So as far as this picture goes here, I've got the circumference, the distance all the way around. The arc length is going to be a part of that, such as the distance between arc AB here. Okay, the length of the arc of the circle is going to be the product of the ratio of the measure of the arc divided by 360 and the circumference of the circle. Okay, so in other words, what I'll do is I'll figure out how much of the circle I'm looking at by taking the arc measure divided by 360 and then multiplying by either 2 pi r or pi times d, which is the total circumference. So both these formulas are doing the same thing. They are just a fraction of the circle circumference. Alright, so let's go ahead and find arc length. What's the length of each arc? In part A, we have arc CD. Now, if that is on the circles, that's the distance from C to D along the outside of the circle. And the formula I just gave you is, we'll say the measure of the arc divided by 360, and then I'm just going to say times the circumference. Since we had two different formulas, we'll just say times circumference. Okay, so the measure of the arc, remember, measure of an arc is just the measure of this central angle here. So since I have the right angle, I know that's just 90. Alright, so we have 90 over 360. And essentially that's telling me how much of the circle I'm looking at. If I reduce that, that'd be a fourth. So I'm taking a fourth of the circle circumference. And then we'll multiply that by the circumference formula. Now, since we gave you the diameter here, we'll just say pi times d, or pi times 9. And then once again, I can do this in terms of pi by going 90 divided by 360 times 9. And when I do that, I end up with a 2.25 pi, and we could say centimeters. Alright, or I could multiply by the pi to get an approximate solution. So I suppose we could say squiggly equal sign 7.1 centimeters for that one as well. Okay, once again, as far as in terms of pi or approximated, just pay attention to what the answer is looking for. Alright, that's part A. Part B is the same idea, finding arc length once again. Okay, again, take a minute, pause the video, run through that, and check your answer before we move on. And the last thing we're going to talk about for this lesson is a couple problems dealing with finding the area of a circle. So here we've got our area formula. Area of a circle is just the product of pi and the square of its radius. So pi r squared. Pretty straightforward. If I know the radius, I just plug that in and I get the area. Alright, so let's go ahead and use that area formula. Problem 9, pretty straightforward. What's the area of the circle? We just said that area equals pi times radius squared. So I guess pay attention to, did I give you the radius? Did I give you the diameter? Here the 18 is just the radius. So we'll just say pi times 18 squared. And again, I can do that answer in terms of pi by just squaring the 18 and saying this is a 324 pi inches squared. All right, or if the question wants me to round, we'll multiply that out to get a 1017.9 inches squared when I multiply through by the pi. Okay, again, either way works, just pay attention to what the question's asking you for. Part B is the same idea. Take a few minutes, pause the video, run through that, and check your answer before we move on. And the last thing we're going to look at in this lesson is finding the partial area of a circle. Okay, or in other words, finding the area of a sector of a circle. I'm going to say the sector of a circle is a region bounded by an arc of a circle and the two radii to its endpoints. So in this example here, we have arc AB. Okay, and when I extend the radii to A and B, from A and B to the center, we get a slice of pi, we get the sector. And they'll say the area of a sector of a circle is just the product of the ratio of, once again, the measure of the arc divided by 360 and the area of the circle. Okay, so once again, just like we had with finding arc length, we'll find the fraction of the circle, measure the arc divided by 360, and then just multiply by pi r squared, in other words, the area of the circle. All right, so let's go ahead and use that area of a sector formula. We want to find the area of the shaded sector, the area of the shaded slice of pi for this circle. And we just said that formula was the measure of the arc over 360. Okay, the fraction of the circle. And I'm just going to write times the area of the circle. So this one's pretty straightforward. Measure of the arc is just 36 degrees over 360. Okay, so in other words, we're looking at 1/10 of the total circle's area. Okay, then we'll just say times pi r squared, so times pi times 6 squared. And once again, I can do that answer in terms of pi. If I go 36 divided by 360 times 6 squared, that'll give me a 3.6. So we can say 3.6 pi units squared. Or again, if the question is looking for it, we can multiply that by pi and end up with the 11.3. And either way, I didn't give you any units here, but we'd say units squared. All right, that's finding an area of a sector of a circle. Okay, last thing for you for this lesson is, once the video wraps up, go ahead and do part B, get your answer checked, make sure you're good with this stuff before we start getting into the homework, before we get into the Math Excel. All right, that's area. We'll see you folks later.